Okay, let's do this. So last time we started talking about the HTTP protocol. We saw HTTP requests. We saw the format, the structure of those, and that's the structure that we'll have to parse on your homeworks, starting with LO1 of homework 1. And the grader is up in AutoLab if you started the homework and you want to see how you're doing on, see if you're done with LO1. Reminder, there's auto grading for LO1 of each homework, but the rest of the 4 LO objectives are all going to be manually graded after the deadline. And there's, I'll say, minimal feedback in AutoLab with the auto grading. I don't think there should really be any, so I am bending that a little bit and giving more feedback than I want. It really gives you very, very little feedback in AutoLab. It's 3 tests that it says whether you pass those 3 or not, and you have to pass all 3 to pass. But you'll see when you submit what that means. This is a brand new auto grader. I've never done any auto grading in 3.12, so if you have issues, reach out to me and I'll fix some bugs. We just saw one in office hours. The AutoLab is currently running Python 3.8, so if you're using any newer language features, that's going to break at the moment. I want to get that updated so you can use your newer features if you're fond of them. But right now, bless you, it's Python 3.8. The first line of the grading feedback prints out the Python version number if you want to check the exact version. But, all right, so with that, we need to learn how to give responses. Once we get to learning objective 2, we have to start responding to these requests. LO1 is just parsing the requests. Now we have to respond to actually host a web page. That's what we want to do, right? So we need to give responses. And the responses are going to be in this format. Very similar format to your requests, but a few differences. And let's get these differences because we got to talk about Docker today too. We got to clean up these slides and get to Docker. So this is what your response is going to look like. I'm going to render our CRLFs as new line characters visually on the slide, so it's more visually appealing. But this is the sequence of bytes. This is a sample sequence of bytes that you can send, in this case, to say hello to the user. This is going, if this is your HTTP response, somebody opens up their browser and goes to your page and you send them this response when they send you an HTTP request, their browser is going to say those 5 characters, hello. And that's it, nothing else. Just hello. But it will say something, it will work, and actually host technically your first web page if you're just responding with hello, no matter what the request is. All right, so let's break this down. The status line, a little bit different than the request line. The request line was your HTTP method, the path, and then the HTTP version. Here, still 3 values, but in a little bit different order. First is the HTTP version. Second is the status code, which is some 3-digit number. And then the reason phrase or status message, whatever you want to call it. In the documents, it's reason phrase. So if you're reading 2616, it's going to be reason phrase. That's what they're talking about there. You have to have 2 spaces in your, at least 2 spaces in your status line. But a little bit different than the request lines, the status message can contain spaces. If you're sending a 404 not found, for example, it's not space found. So you can have spaces in your status message, but anything after the second space is going to be considered part of that status message. So slightly different, but we don't have to parse these things. We just send them, so we don't have to worry about that too much in this course. The response code, these have a lot of meaning. You'll get to know quite a few of these throughout your careers, throughout this semester even. Just a quick overview for the time being. Any 200 level code, meaning any code that starts with a 2, so anything in the 200s, is going to be an okay, everything went great, here's your content code. Everything's fine. You'll never really notice these 200 level codes as an internet user because you're just going to be looking at the content that you requested. You'll never notice that you got a status code, but it's usually 200. 200 is going to be the most common status code that you get on the internet when you're sending these HTTP requests. A 300 level is a redirect. It's sending you to a different page. And any 400 level means user error. These are the ones that we see as users. 404 not found, 403 forbidden, 401 unauthorized. These 400 level errors means you did something wrong or you requested, or more accurately, more often, you clicked a dead link. The dev still did something wrong, but it's still a user error because you requested something that doesn't exist. And then 500 level codes, the stuff of nightmares for us developers. This means the server had an error. Something went wrong server side. that the user didn't do anything wrong. Well, usually the user does something strange to get these, but it means that something broke so bad on the server that we couldn't even generate a proper error code, and it's usually just 500, stuff's broke. I can't, internal server error, I couldn't think of it off the top of my head. 500 internal server errors. Somewhere in that server, something broke. And that's when you have, I gotta get the lecture channel open, I didn't have it open. And that's when you might be getting a phone call at 2 in the morning or something. You got to fix your site because users want to use your site and it's broken. 500 errors are very, very scary. And then the human readable, the response code, that's for the browser. The browser's going to take that code to figure out what this thing means. If it's a 300 level, it's going to look for where it's being redirected to, or whether it should give an error message for 4 and 5. And then after the 3-digit code for the computers to read, then it's the human readable phrase after that. There's nothing magical about the human readable phrase. We should be consistent and actually say what the code means, but the browser's not going to care if you, if you do that in lowercase. The browser's actually not going to mind that. But you should keep your phrases consistent with what that code, what the response code actually means. Headers are in the same format as with messages we receive. So with HTTP requests, HTTP responses, same format for the headers, but there are 2 headers that you're going to have whenever you're serving up content to the user, and that's content type and content length. These 2 headers must be set if you're sending any content. The content we're sending is the 5 characters hello. So we need to tell the browser what this content is. What is this thing that we're sending? After all the headers, after that blank line, we got some bytes of information. What is it? Well, we're going to tell it through content type what type the content is. I guess that one's straightforward. What type the content is. In this case, it's plain text. So we have text/plain is the way we're going to identify that this is plain text that's being sent. It's just the 5 characters hello. It's not HTML, it's not CSS, it's not an image, it's nothing else. It's just plain text, straight up plain text. So text/plain. Next, I believe it's Monday, we'll get into that a bit deeper of all the different content types that we'll use in the course and what exactly that means. We'll break it down further. For now, text/plain will be the only one we'll see, and we'll be fine with that. Content length, we'll also talk about this at length. We'll also talk about this a lot next week. For now, I'll keep it brief. Content length is the number of bytes in the body of the response. Number of bytes. Everything after that blank line is the body of the response, so we have the headers and the body. Everything after the blank line is the body, and this is how many bytes are in the body of the request or of the response. How many bytes? That's going to be very important. I'll wave my arms around and shout about it when we get to where that's important, but the TLDR of it is these characters are 1 byte per character, so it happens to be 5 here because we have all ASCII characters, but when we have more complex characters, 1 character might be more than 1 byte, so make sure you're not taking the length of the string to compute your content length. It's always the number of bytes to represent the body of the response. Number of bytes, not the length of the string, if you're serving up text. Then a blank line, very, very, very important. We need this blank line, the CRLF. This tells the browser, for the GET request, it wasn't that big of a deal. It just said this is the end of the request. Here it's a much bigger deal. This blank line, this CRLF, this sequence of 4 bytes, tells the browser, I'm done with headers, and what follows is going to be those 5 bytes of the body. So it reads the content length, looks for the blank line, and then it knows it's reading 5 bytes after that blank line, and then that's the juicy content. That's what we're actually sending to the user. If we don't have that blank line there, or if our new line characters are /n/n instead of CRLF, browser's not going to find the data. It's going to break their parsing code, and things aren't going to work. So we need that blank line there, and we need our new line characters being CRLFs. And then finally, the body itself. If we want to send a 404, It's the same way as a 200 OK. It follows the same structure as what we just saw. And whatever you put in the body of the response, that's what's going to be displayed to the user. So with modern sites, usually this is HTML, and it's a whole page that's rendered. For our purposes, so far, at this point in the course, we're just going to send some text. Actually, with 404s, you can always send text like this. I don't really care. We don't have to get too fancy with that. But our 404, whatever you send, it's going to be rendered just like a 200 OK, except we're going to send our 404 message to say, hey, whatever you requested, it's not there. You gave a bad path, and serve up your 404 like this. So put your 404 not found, and then whatever message you want to send the user to say, content's not there, bro. Whatever you want to add for your message. And the homework says whatever you want, whatever message you want. If you want to make it HTML, go for it. Hey, all right. Any questions on this? That kind of went fast, but it's clean up from last time. And the responses aren't too, oh, no. All right, this is fine, this is fine. Hey, I just didn't refresh. So is the old URL. Okay, any questions on requests, responses, HTTP? On Monday, we will get deeper into more details, but I will assume that you understood that stuff. So any questions on that before we dive into Docker and Docker Compose? Okay, everybody's proficient with HTTP. At least the format. It takes a while to write the code to parse and to generate the responses and stuff. But I'm assuming you're all good on the concept. All right, Docker and Docker Compose, let's do it. A little bit of vocab I want to introduce. I'll use this throughout my life, but definitely throughout this semester. Dev and prod, our development environment and our production environment are two different environments. Your dev environment is your laptop, your desktop, wherever you're working on code. That's what we call dev. And then prod is wherever you're deploying to your end users, where you're finally ready to release your app. We can have bugs in dev, that's fine. That's where we write bugs and fix bugs. But prod, we want to do whatever we can to avoid bugs there. So lots of testing in dev to make sure our bugs don't make it to prod. And there's a lot of issues here. You've had a lot of these. The old, it works on my laptop issue. I just had it in office hours yesterday. I ran my grading code, and it worked fine on my laptop, but in Autolab it didn't work great. And it was the discrepancy between Python versions, which wasn't entirely unexpected. That wasn't too big of a shock. But still, these issues are a pain, and they do happen. When we go to push to prod, we get our latest code in prod, and things don't work, but in dev, everything worked perfectly. We want to avoid these as much as we possibly can. Maybe I should have had another layer of containers to test that, so I didn't have that issue in office hours just now. And there's lots of things that can cause this. I'm not going to read this list. I'm not going to go through it, but lots and lots of things. I guess I just gave the example of different Python versions. Lots and lots of different things that can cause this. When you have one environment set up on your laptop with one OS, with certain versions of all your software, then you go to prod and it's a different OS, and everything's just completely different. It's probably running on a server that doesn't have a screen. For example, auto-grading Java programs that use GUIs. We can't run the GUI because the server doesn't have a monitor, and it doesn't have any hardware for that. So whenever you try to create a window, it crashes. So we have to separate the GUI from the functionality code because we can't run the GUI. Like, we can't just run the GUI and have it not display anywhere. It just actually crashes. So lots of things like that. Different environments are going to have different bugs and different issues, different concerns. So our solution is virtual machines. We're going to simulate an entire machine, all the software, the operating system, every version of every piece of software. We just simulate that, package it up in a VM, and then we can run that VM in dev. We can run that VM in prod. Problem solved, right? This is a great solution. This is mostly how we used to get things done because it's an exact copy of the same exact environment. So we have that environment in dev, that environment in prod. The environment is detached from the host OS, from the host device, and we're running the same exact environment in both situations, in dev and in prod. So this is great, but if you've ever used a VM, you know that this takes up lots of resources. It's tough to, I want to say dual boot, but that's the wrong phrase. But if you have two OSs simultaneously running on your machine, you have your VM and your host OS, it's very resource consuming. If you have a very powerful laptop, you can get away with it, but it takes up a lot of resources. You have to dedicate a certain number of cores, a certain amount of RAM to that VM that it just hogs up and it takes away from your host OS. So it is a solution, but it's has some issues, but it does answer the problem. One is security as well. So ease of life, like deploying to prod, that's the biggest thing. But also security. This is an important feature that we get from VMs as well, that the user shouldn't be able to break out of the VM. So if we have our app running on a VM that's running on a server in a server room, an attacker who hacks into that app, shouldn't use the word hack, but who compromises our app and gets into our app can't, or at least shouldn't be able to break outside of the VM and destroy things beyond that. They shouldn't be able to get to the box, the server box, and they shouldn't be able to escape that box, get into our network, and take down the whole server room or get all of our information that's hosted in that server farm. They shouldn't be able to do that. Hopefully they compromise the VM and just get the VM, and then we can just wipe that away, say, well, that VM's compromised. We find and fix the bug, patch the vulnerability, and then redeploy a new VM and have our app back up and running with minimal damage. Still severe damage. The attacker can still get private data and do a lot of damage, but it can be limited, at least to a degree. And there are some apps that need this behavior. There are some apps that are designed to run untrusted code. AWS, DigitalOcean, and Autolab, the one I'm most familiar with. Autolab, the whole purpose of Autolab is to take your code and run it. If your code says, make a syscall for rm-rf/, we don't want you to be able to nuke the entirety of Autolab. If you do compromise Autolab and find a vulnerability, we don't want you to be able to get everybody's grades. So that's not how Autolab works. We take your code and run it in an isolated environment where you can't really break anything except that environment, and then after your code is executed, that environment is completely destroyed, and then next time you make a submission or somebody else makes a submission, we create a brand new environment, destroy it. Every environment, it's a whole new instance of Ubuntu that's used for one thing, just grading one submission only, and then it's torn down right after. So this is a way that allows us to run insecure or untrusted code in an isolated environment. If we use VMs, which, of course, we don't use VMs, we're going to use containers. So containers have all those benefits. They're effectively VMs, but they're much more lightweight. They're not as resource intensive, and it's much easier to share resources among containers. The containers we'll use, they will use a hypervisor. I shouldn't go into the details because I don't know all the details of how it works, but it uses a hypervisor to share resources between multiple containers. So if a container needs resources, it can take them up on demand without taking a core and a few gigs of memory and having that dedicated to that container. It can instead share a pool of cores and memory across many containers. You can run, if your containers aren't really computing all that much, you can have hundreds of containers running on your device simultaneously, and it's just not a big deal. Can't quite do that with virtual machines because they need so much dedicated resources. So we have effectively lightweight VMs and containers. This is pretty much, bless you, pretty much how we deploy these days. If you go out there in the workplace and they're not deploying with containers, come after you graduate, send me an email or something, let me know, because I would be absolutely surprised if anything more than a company with like a startup with startups should still be using it. No, I would be surprised if anything out there in the industry that has actual end users actively using their site is deploying some way that's not using a container. It'd be pretty Pretty surprised these days. It's pretty much the answer. It solves so many problems, so many headaches that we used to deal with all the time. They're solved by this. If my coworker's running Windows and I'm running Linux, I don't have to care because we're both just going to work on the same container. We're both going to deploy to Ubuntu anyway, and we don't really have to worry about differences in environments and do we write the code for Windows, do we write it for Mac? I don't know. We're going to choose an OS for the container and write it for the container. And we're going to use some Linux distro because it's free. We don't have to worry about licenses for our deployments, among other reasons. But we deploy with Ubuntu usually, some Linux distro. So Docker is the software we're going to use to orchestrate our containers. I shouldn't use the word orchestrate, but to create and run our containers. Or container orchestration is a whole nother level, a whole new layer, another layer on top of this, using things, you know what, we don't have to go and get into it. But Docker is the software we're going to use for this. This is software that runs on your machine, so this will have to be installed on your device so you can test your homework assignments before you just submit and pray. I've had students do that in the past. It almost never works out for them, where they have some trouble with their Docker installation, and they'll say, I don't need Docker. I'll just set it up, eyeball it, and hope that my configuration is perfect. And they submit, and they get zeros on their assignments. Make sure you install Docker. It can, I mentioned this last time, but it can be hit or miss. Some students have a hell of a time installing Docker. Some students, you just type one command and everything works perfectly. So if you haven't installed it already, get on that to make sure you're not one of the unlucky ones who's going to have a pain installing Docker. Because if you are, that's extra time you got to spend installing it. Hopefully nobody does. I'd like to have a semester where nobody has any Docker installation issues, but it's just not the world we live in. There's usually about, up to 5 students, or at least that I hear about, that have Docker installation issues. So get on it early. Make sure you know if you're going to have issues or not. Hopefully you're all just going to Google install Docker, click a few buttons, and be done. But this does need to be installed. We install Docker in dev. We install Docker in prod. We work on the same container. And then it's the same container in dev. It's the same container in prod. And then the Docker installation handles the gap between host OS to container OS. To get Docker to work, we have to have something called a Docker file. And this is where we're finally going to get into what we have to do to get Docker up and running. So Docker file, it's similar to a makefile. You've all seen makefiles. I believe in 220 you still have to use them. In that it's a script, it's a text file that's a script that's going to execute to build your Docker images. I haven't used the word image yet, but to spoil what's coming up, we're going to build Docker images and then use those images to create Docker containers. So we can create one image and then create like 100 containers that's made from that image. But we have to build the image and then run the container based on that image. Content link needs to be exact. No, it needs to be exact. Has to be exact. Down to the byte. Has to be exact. The problem is, so you're not really like asking for space. It's not like malloc where you were like, I need this much space. This is giving the browser a heads up. Hey, I'm going to send 5 bytes. If you say, you know what, just to hedge my bets, I'm going to say I'm going to send 6 bytes, but I'm only actually sending hello, and I'm only going to send 5 bytes. What the browser is going to do is it's going to hang, because it's going to sit there and go, you told me 6 bytes, I will sit here and wait for that 6th byte, and your page never loads. So it needs to be exact. If you say 4 in that example, it's just going to be, I shouldn't use 4, 3 in that example, it's going to be HEL that's sent to the user because the browser is going to read 3 bytes because you told it 3 bytes. It's only going to read 3 bytes. So that does have to be exact or else your page isn't going to work the way you expect it to work. No, Ken already answered. I should have just said, Ken's got you. All right. So Docker file, let's talk about it. So this Docker file, I'll tell you right up front, this Docker file is more complex than what you need to do in your Docker file configuration, but I want to make sure I get the concept and the theory and how to use Docker out there This one lets me talk about all the things I want to talk about with Docker. And those of you taking other courses that use Docker that don't really talk about it have in the past found this useful. So let's talk about this, even though this is a little more than you have to do in this class. So let's break this down. I'll go through it line by line, part by part, and talk about what Docker is doing when it reads this Docker file. So right from the first line, where else would we start but the first line? So we don't create Docker images from scratch. I guess we could. I don't even know how we would do that. But we don't create Docker images from scratch. We're going to start with an existing Docker image and then just add whatever we need to add to that image. For this example, I'm going to start with an image that already contains a fresh install of Ubuntu 18.04 and start with that. So this from line from Ubuntu 18.04 is going to go out there to Docker Hub out there on the internet, find an image named Ubuntu 18.04, which of course exists, and it's going to download that and then use that as the starting image. So we start with a fresh instance of Ubuntu, just like that. One single line, we have Ubuntu installed. Easy as that. The hard part is installing Docker, which sometimes that's even easy. So we have a fresh instance of Ubuntu, and we want to set it up to be able to run our web app. The next line here, we're going to use this run command, which we see all up and down this thing. Run is going to take a command and run it as though you typed it in a bash shell. As if you open up the command line and just typed out this command. So I want to update apt-get, update my repositories. So the very first thing I'm going to do is run apt-get update. And you don't need any sudos here. You're running as the root user. So you don't have to do sudo apt-get update. It's just apt-get update. Leave off all your sudos. Don't need it. We're already root. We have root access in our container, especially when the Docker file is running, when Docker is running the Docker file. The next two, this is optional, but I always like to do this, and it lets me talk about a few different things. Environment home / root. This is setting your home environment variable to root, which sets your home directory to root. So when you do cd space tilde, that's going to take you to your home directory. In this container, that's going to take me to /root. So I'm setting this directory as my home directory. And then the next line, working dir /root, that's going to change my working directory to /root. This is the same as typing in cd /root. That's going to set me into that directory. So now I know two things. My home directory is /root, and I'm currently in the directory /root. That helps me know where all my stuff is going to be, and it makes sure that my current directory and my home directory are in sync. This might, I should look it up someday. I always just do this anyway. I think I got it from some documentation. It just stuck with me because it makes sense to me. This might be the default directory structure, the default working directory. I don't even know. But you know what? I don't have to care because I'm going to have these two lines in all my Docker files. And then if Docker changes the default directory someday, or whatever image I grab maybe has a different default directory or default home directory, I don't have to care because I'm overriding whatever the defaults are, so I know what they're going to be for sure. I don't have to rely on defaults. So when we submit to AutoGrader, it downloads new Linux every time? No. So LO1 of each homework isn't going to run through Docker. So learning objective 1 is just testing your request.py class. It's not testing any Docker configuration. Then for manual grading after the submission, after the deadline, the other 4 objectives, the TAs are going to manually run Docker and do a fresh instance of Ubuntu every single time. But the AutoGrader and AutoLab isn't. Actually, I take that back. It kind of is. But it doesn't download it every time. It downloads the image one time and then uses that image to create new containers. Because it does at the other level, because when you submit, your submission is graded inside a container, but it's using the image. It's not re-downloading the image, but it's using the image that it already downloaded. And is creating a new container every single time. So a new container is created every single time you submit, but it's not downloading a new image. And Docker is really smart about not redoing work. It's much like Git in that sense. If you change like a line halfway down this file, the first half of the file is not going to redo any of that work. It's only going to start at the line that it detected a change on and then start from there. So there's a lot of avoiding redundant work in Docker. Okay, and then anything we need to install to get our stuff to run. Very important step. For the simplified Docker file, we're going to avoid all this. But if you're using Docker for anything more complex and you need certain tools installed, any number of run commands that you need, as if you were, because that's literally what we're doing, is going to a brand new install of Ubuntu 18.04. What commands would you have to type to install all the software and all the tools that you need to run your app? In this case, we're installing everything to run Node and NPM, because this example is going to be a Node app. If you don't want to think about that, that's fine. But anything that we need to install, if we need to install Java, if we need to install Python, if we need to install pip, anything that we need to install to be able to get our stuff running, any number of commands that it's going to take, can be dozens, often is the case, but whatever you need to install to get your stuff running. Bunch of run commands. And then copy ... Very, very important, and the order is very important here. Copy ... What this will do is copy everything. It'll copy this file, just bear with me a second, into this file from your local system into the Docker image. If you give it a directory instead of a file, it will copy all the contents of that directory, and dot means the current working directory. So this will copy everything from the directory of this Docker file recursively into the container's directory, present working directory, current working directory, which we just set to /root. So in this example, it's going to copy everything from your project directory into /root inside the container. If you want to do something different here, you want to give this a file name into a file name and then have multiple copy lines. If you want to copy certain directories but not others, you can change this. ... is kind of the overkill. It's the sledgehammer approach. Just copy everything in this directory into the home directory inside, or the working directory inside the container. So if you want to do something different, definitely flexibility here. Copy ... is the easiest approach. Not always the most elegant approach, but the easiest approach. And then download any dependencies that you need. Install any dependencies. This is where order really matters. If you're not thinking about this Docker file, not thinking about what these lines mean, you might be tempted to just pile them all into a file, and you might end up doing this npm install before copy ... npm install, to relate it to Python, this is like running pip install. It's the same idea. It's going to read your package.json file, look for any dependencies that need to be installed, and install those dependencies. Or in Python, pip install pip-r install, I think, whatever the command is going to read your requirements.txt file and download all those packages and link them to your project. In 1.16, we used Maven and a I'm blanking on it. We'll get it. YAML, something YAML, something. We used something. Oh, what did we use? What was it called? I don't know, but it was something. I should know. It's going to come up in lecture in a few minutes here. It's going to bug me. Oh, well. I'm sure it's that important. But whatever the file is that had our dependencies in Java, it would be the same thing here. Maven install those dependencies. So that's what we're doing here. So if you don't have your dependencies file in the container, guess what this command is going to do? Nothing. Not going to do anything. So you want to make sure you copy your files into the container, or at the very least, copy in your dependencies file, whether it's your requirements.txt, your package.json, or your, man, I wish it would just come to me right there. You want to copy that file in before you try to install your dependencies, because you're going to install your dependencies in a fresh instance of Ubuntu with no files, none of your files in it anyway. It's not going to do anything. So make sure you copy your files in before installing your dependencies. And if you have a compiled language, Java, C++, C, whatever, you might want to do all your compilation while you're building this thing as well. Compile your code, so install your compiler, copy your files in, compile your code, generate all your class files, all your compiled files, and then do the next steps. What's the next step? which is actually optional for all of our purposes, but I still want to talk about this just to say that it exists. Expose 8000 here. This is exposing a specific port from inside your container to the outside world. So by default, all the ports in your container are blocked off. Docker won't let anybody access any port inside your container. But if I say expose port 8000, that's going to say Docker, let people access port 8000. Expose that to the outside world. We don't need this because the next thing we're going to talk about, Docker Compose. When you map a port using Docker Compose, it will implicitly expose it in Docker as well. So we still have to do this, but we end up doing it through Docker Compose. So it does end up being optional. But if you weren't using Docker Compose, you were just using Docker, you would need to expose whatever port you want to expose. And then the last one, the big important command. This is the one and only command that's going to be executed when you run your container. Everything else in this file, every single line, especially the difference between run and command, very important. Everything else is going to run when you're building the image. When you build the image, all the runs are going to execute. When you run the container, that's when the one and only command is going to run. And I say one and only because you cannot have more than one command. You can only have one in your Docker file, and that's the command that's going to execute when you run your container. When you run a container that's created off of this image. And that's, for our purposes, in a web apps course, that's when we want to start our app. So this would be Python 3 server.py or node app www.js in this example. But this is the command that you would run to actually start your server. Can we run an instance of any OS using Docker? If there's an image that exists out there, then yeah. I don't think there's any images for like OS X and Windows because they have aforementioned licensing issue. How are they going to issue license? How is Microsoft going to charge you? How's Apple going to charge you for those? So I don't think those exist, at least not publicly available. They probably exist somewhere on the internet. But any Linux distro you can think of, I'm pretty certain there's probably like at least 20 different varieties of containers that you can download. And in Ubuntu's case, thousands, if not hundreds of thousands. All right, any questions? Actually, the questions are talking about my next slide, so I probably should just get to it. Jarl. It's definitely a YAML file. No, it's an XML, pom.xml. That's what it is. I got hooked up on YAML. It wasn't even a YAML file. The pom.xml that we used in 1.16 to specify all our dependencies, and then we use Maven to install our dependencies. That's where it says npm install, we'd have Maven install, and it would read our pom.xml. I definitely mean something else. So image, that's going to be, I have a bullet point on a feature slide, but I'll say it right now. An image is like a class, and then a container is like an object. So our image is our template that we're going to use to create containers. Definitely not a picture. But that's what this Docker file is going to create. This Docker file, all the lines except command are going to execute to create our image, which is our template to be able to create containers. Then we'll create instances of that image, which are our containers, which is the part that we're actually interested in. And yes, there are images for specific languages. Here's one. If we want to condense that previous example quite a bit, we can start with Node, an old version 13, but bless you. But there's newer versions of this of this image. You do from Node, whatever version of Node you want to run, and that already has npm installed. It has Node installed. It has all that stuff already there. So all those run commands, we don't need them anymore that we were using just to set up our Ubuntu. I'm still going to use my /root stuff. I like that, so I know what directory I'm working in. I still need to copy my files in and install my dependencies. That's project specific, so you'll have to do that. There's not going to be an image with your project already installed on it, unless you are hosting it, unless you shared it out there on the internet. Still have to expose whatever port we want to expose, and then run our command. And yes, there is one for Python. Again, Python, you might not want to be like me in AutoGrader. I got to update my Python and use 3.8, but whatever version you want to use from Python, and choose your version. Make sure there is a Docker image out there, or just try it. It's just going to say image not found if it doesn't exist. But if you want to do like Python 3.11, probably is out there. It'll probably just download and work just fine. I would imagine that one's out there. And with Python, it's not npm. We're going to use pip install -r to install your requirements. If you have requirements, please don't be like the students who copy my stuff right from the slides. By the way, with Docker and Docker Compose, I'm not even mad if you copy these ones from the slides, so I don't want to stop you from doing that. Whenever I show code like this, I understand and accept that you're going to just take it, and I do allow that. That's fine. But don't take it blindly. You have to understand what you're taking does. So don't be like the students who copy it and then get an error that says can't find requirements.txt, and they never created a requirements.txt file. Like, I think I might even have it in the starter code, so this probably won't be an issue anymore. But students used to do that, like just blindly copying my code with no understanding of what I spent a whole lecture waving my arms about, and then file not found. Did you create that file? Do you have any idea what you pasted? Please understand what you're pasting if you're doing that. But if you have a requirements.txt, that's the way to install it. And don't miss this little -u, this little guy right here. Make sure you have this, and this is one reason why I don't mind at all if you copy my Docker stuff. Understand it, and anything you need to fit to your needs, change it. But this little -u will save you hours and hours of headaches. Make sure that's there. What this does is makes your Python program unbuffered. Docker will buffer your Python output to standard out and standard error, so you won't see your error messages or your print statements when you run your Python code in Docker most of the time. But if you hit this -u, then you will see all of your error messages and all of your print statements. That -u, that's a very important 2 characters, 3 if you include the extra space that it takes. Very important few characters there. I don't know what I'll update Autolite. I don't know what the latest version of Python is right now even, but I'll update it to the latest one that's convenient for me to set up, because I'm using Docker images and stuff. As long as the latest version is able to, easy to update, I'll use that one. Okay. Oh, we're not even going to get to Docker Compose. Well, we'll get to the start of it. So now that we have a Docker image, we're going to use Docker build -t image name and then dot. That trailing dot is not a typo. That's very important. That says look in whatever directory you specify for a Docker file, for a file named Docker file with a capital D. I think it does have a progression that'll look for a few, like Docker file with a lowercase d and stuff like that. I think it has a progression, but Docker file with a capital D, if you name it that, you're never going to go wrong. Dot is present directory, so run this command from the directory containing your Docker file, and it'll find that Docker file, and it'll build your image with whatever image name you give it, which is fine, but what we actually want are containers. If we could only create images, this would be completely pointless. What we actually want are containers. That's what actually does things. Just like a class, we never want to create a Java class if we can't create objects of it. I guess with the exception of static methods. I shouldn't have went down that one. But anyway, we want to create containers. So to create a container from an image, Docker run -p to map ports, and then the image name. So whatever image name you chose from the previous slide, you would run this command, choose your local port from your device, and then map that to a port inside the container. So in this example that we've been using so far, inside the container, the app's been running on port 8000, and I actually don't care what port you run your app on at all. You can run it on whatever port you want. But local port, the homework always says local port has to be 8080. So whatever you map that to inside your container, whatever port you choose, I recommend just using 8080 in both instances because it's easy to remember. You don't have to mess with it. And then you don't have the, oh, I did the wrong port when I submitted, and now you have ones on all your objectives, and you're in danger of failing the course. Don't be that person. Don't do it. Make sure you're hosting on 8080 as your local port. Whatever your port is inside the container, I don't care for the homeworks. But anyway, what this is going to do is map this port on your device to this port in your container, and then actually create the container and run the container. It'll run that command, start your app, and now you can go to your browser, localhost, local port, whatever you chose, 8080 in our homework, and it will send a request. It'll send a GET request to your server, and if your server is working right, you should be able to see your web page at that point. If you want to run this in the background, -D isn't super helpful in this class because we're always in dev, but when you go to prod, hit it with a -D, and that's going to run this in the background forever, so you can be hosted to your users forever. In your code, any documentation you read up on, like how to start a TCP server in Python, this is already in the handout code, so you don't have to think about it too much these days, but I used to make students do this. Never use localhost for your host name of your app. Use 0.0.0.0 as the host instead. The difference is 0.0.0.0 opens you up to everything, which if you use localhost, you're closed off to Docker, and Docker can't access your app. And if Docker can't access your app, nobody can access your app from outside the container, which is what we want. So the easy fix is using this as your host name instead of localhost. Okay, I think that's plenty for today. I don't think we're gonna really get into that. Where exactly is the command line? I don't know if I can answer that in a short amount of time. Command line, it depends on your operating system is the shorter answer. Like on Mac, it's your terminal.